Okay, here we're going to look at factoring. There's a couple different types of factoring. The first type we're going to talk about is GCF factoring. This is greatest common factor factoring. Basically, this is undistributing. So you've gotten really familiar with distributive property. Here we're going to undistribute something. So in this case, if we had 3x squared plus 18x to the third, what we did is we took out the 3x squared. So we undistributed the 3x squared. So likewise, if you distribute this 3x squared in, 3x squared times 1 is 3x squared, and 3x squared times 6x would be 18x to the third. So the idea behind GCF factoring is you want to find what is in common with both of these. Well, I noticed 3 and 18 are divisible by 3, so that's why I took out the 3. And then they both have x's in them. And more specifically, they have x squared here and they have x to the third here. So the greatest common factor there would be x squared. So that's why the x squared came out. And then what you have to do is divide 3x squared by the 3 and the x squared. You get 1. And divide 18x to the third by 3x squared, and you get 6x. Okay. The other type of factoring is unfoiling. So with foiling, you take the first times the first, which is, in this case, x squared. So let's write this out. And then the O stands for outer, so it would be x times 2, which would be 2x. The I is inner, so 4 times x is 4x. And then the L stands for last, so 4 times 2, which is 8. So if you FOIL this, you end up with this over here. So we want to figure out what did we FOIL to get x squared plus 6x plus 8. And that's what we're going to talk about today in this video. So the first type are some GCF factoring examples. So what is in common in both of these terms? Well, I know 3 is divisible by 3, and 6 is divisible by 3. So I can take out a 3. And then what's left over, if we do 3 divided by 3, that's 1. Plus 6 divided by 3 is 2, so it would be 2x. And the way to check is you distribute the 3 in. You get 3 plus 6x, and that's what you want. Okay, here, I know 4 and 6 are both divisible by 2, so I'm going to take the 2 out. And then r to the third and r are both divisible by r. So if we take the 2r out, 4 divided by 2 is 2. R to the third divided by r is r squared. And then minus, well, 6 divided by 2 is 3. And r divided by r is nothing. So it would be minus 3. If you distribute that 2r in, you get 4r to the third minus 6r. Okay, this one looks a little mess here. 13 is only divisible by 1 and 13, and 7 is not divisible by 1 or 13. So there's no common number we could factor out. We've got g to the fifth and g squared. You could take out a g squared. And we have an f squared and an f to the fourth. We could take out an f squared. So if we do that, if we take out a g squared here, we're left with 13g to the third. And then well, the f squared is gone now because we divided that out. And then over here, we get minus 7. The g squared we took out, and so that disappears, and we get f squared here. F to the fourth divided by f squared is f squared. So if we distribute this, we'll end up with the blue stuff over here. Okay, and then this one you're going to use in a different lesson, but this one's, it's actually kind of done for you. You have 3x times this stuff, plus 4 times this stuff. Well, it has a 2x minus 3 in both cases, so let's pull out a 2x minus 3. And so what's left over is 3x plus 4. And this will come in handy actually later this video. We're going to use that idea. Okay, the other type is the unfoiling. This is factoring quadratics. So we're going to set up our foiling parentheses and figure out what did we FOIL to get this. Well, I know the first term has to be x and x. And all of these examples are going to have nice integer integer answers. So you're not going to be dealing with like x plus 3.2 or something like that. So I know x times x, that's how I'm going to get x squared. And then I know I need to end up with a 3. So this number times this number has to give me positive 3. There's really only one way to do that using, well, there's two ways. You could do x plus 3, x plus 1, or you could go x minus 3, x minus 1. Well, I know it's not going to be minus, because the middle term is going to be positive 4x. And how does that make sense? Well, if we FOIL this, x times x is going to be x squared. X times 1 is 1x. 3 times x is 3x, so 1x plus 3x, that's 4x. So the middle term kind of tells you what sign these two are going to be. So let's look at the next one here. What did we FOIL in order to get this? So I know it's going to be x and x. I know the last two have to multiply up to 24. So the multiples of, or the factors of 24 are 2 and 12. They're 3 and 8, 4 and 6, and then 1 and 24. That kind of exhausts them all. So which of these will add up to 14 is what I'm asking. Well, the 2 and the 12. So it's going to be x plus 2, x plus 12. Okay, so now we get some negatives in here. Let's see what that changes things. What did we FOIL to get this? Well, we know it's going to be x and x. And then we need to get factors of 6. So 1 and 6, 2 and 3, and that's it. Well, both of these could give me negative 5. I could have 1 and negative 6, or I could have negative 2 and negative 3. Well, the problem is if we do 1 times negative 6, that's going to give us negative 6 here, and that's not what we want. We want positive 6. What about negative 2 times negative 3? Oh yeah, negative times negative is positive. So it's going to be x minus 2 times x minus 3. And if we FOIL that, we get x squared minus 2x minus 3x. So we got minus 5x. That's what we're looking for. And then negative 2 times negative 3 is positive 6. So that's good. Okay. And then the last example here, it would be, let's see, what did we FOIL to get this? So it's going to be x and x. And then we want to know what numbers multiply up to 36, or negative 36, I guess. And so we got 1 and 36, we've got 2 and 18, 3 and 12, 4 and 9, 6 and 6, and that's pretty much it. Which of those will give us negative 9? Well, it looks like if we have positive 3 and negative 12, that will give us negative 9. So it's going to be x plus 3 and x minus 12. And 3 times negative 12 will give us negative 36. Okay, so the other part, why do we factor it? Well, factoring tells us what the answers are if it's equal to 0. So you'll often see, find the zeros of this. So what they're saying is, figure out when that equation equals 0. So we already factored these. I just wrote down the answers here. It says, when is this equal to 0? Well, if x squared plus 4x plus 3, that's the same as this expression, x plus 1 times x plus 3. And that's something that's really tough for kids to understand, that this is the same as this. All we did was we're not FOILing this out, we're just leaving it in factored form. So these two are the same. So the thing is, if this equals 0, there's only there's really only two ways that this can happen. If the first part is 0, or the second part is 0. Now let's think about that. If we have two numbers, let's say x times, I don't know, let's say x times 5 equals 0. Well, what times 5 is 0? There's only one answer for that. It's 0. So x is going to be 0. Well, here we've got two different things. We got something times something equals 0. Well, either this part is 0, because 0 times this is 0, or the second part is 0, because something times 0 will give you 0. So there's two answers. Remember, we said before, if you have an x squared, you always have two answers. So it's going to be x plus 1 equals 0. That's going to be one of the possible answers. Or x plus 3 equals 0. That's another possible answer. So we solve this. We subtract 1 from both sides, and we get x equals negative 1. This is one of our possible answers. And then here, we solve this one. We subtract 3 from both sides, and we get x equals negative 3. So our two possible answers are negative 1 or negative 3. Those are the two answers that make this equal to 0. So the same thing with all the rest of them. If we have x plus 12 times x plus 2 equals 0, well, either x plus 12 is 0, or x plus 2 is 0. So in this case, x would have to be negative 12, and here x would have to be negative 2. X equals negative 2. Okay, in this one, same idea. If x minus 3 times x minus 2 equals 0, then either x minus 3 equals 0. Oops, x minus 3 equals 0. Or x minus 2 equals 0. So here x would equal 3, or here x would equal 2. And then lastly, you could do the same thing. X would equal 12, or x would equal negative 3. Okay, so we're going to stop this video here. This is kind of the first part of factoring. The second part of factoring is coming up next, and that's going to look at factoring where it's not quite as simple. It's not just an x squared out in front.